Hi, my name is Bill Cordua and I'm a geologist associated with the University of Wisconsin River Falls. It's my purpose in these series of short films to give you an appreciation for the wonderful geology that surrounds us all here in Pierce and St. Croix counties. I'm in Baldwin, Wisconsin near the Municipal Center and Library by this really remarkable boulder. This boulder was unearthed during housing construction nearby, and in the fall of 2011 was moved to this site by the library, where it was sort of adopted by the community, who term it the Baldwin Boulder. It took quite an operation to move it to this spot though. A local towing company, Day and Night Towing, sent its largest vehicle. This proved just able to move the rock, whose weight was estimated at 50 tons, to its new home at the Baldwin Library. Even though this rock looks pretty weird, it's actually a relative of granite, although it has a little bit of different chemical composition and these extraordinary big crystals in it. The pink and white crystals are feldspar, and they're as big as a head. Such a rock forms by slow cooling deep in the earth in the presence of a lot of water vapor. This rock isn't anything like the local bedrock in the Hudson area. In fact, to even find rocks similar to this, you have to go well over 100 miles away to the north or to the east. Well, what could have moved such a big boulder other than a towing company? The answer, of course, is glacial ice. Glacial ice is a very powerful, if slow-moving, erosional agent. It can transport huge boulders many miles and leave them behind as the ice melts. Geologists call these far-traveled rocks glacial erratics. Farmers call them many other things, including pains in the neck. There's a joke about the city guy that was walking by a farmer clearing his field of rocks. He asked the farmer, he said, well, where did all these rocks come from? And the farmer says, the glacier brung them. And the city guy says, well, where's the glacier now? And the farmer says, I don't know. I guess it went to get some more rocks. Well, that does raise the question of where did all the glacial ice go? And that gets us into the story of the rhythm of the ice ages. During the last 2 million years or so, the Earth's climate has shown periodic changes marked by glaciations and interglacial periods. There have been maybe 7 pulses of glacial advances during the ice ages. We are now in an interglacial period where glacial ice has nearly disappeared from the Earth. We could argue about whether or not human effects are going to lengthen or intensify this period, but that's really another issue. This map from the Wisconsin Geological and Natural History Survey shows the distribution of materials left by these glaciers. We call this glacially derived material glacial drift. The southwest corner of Wisconsin has little or no glacial debris, and that's the so-called driftless area. Around Pierce and St. Croix counties, we have glacial ice from several older glacial advances, as well as the most recent advances. The arrows on the map show the direction of inferred ice motion. The glacial advances that covered River Falls and Baldwin are shown in darker blue, and that glacial period ended about 800,000 years ago. So much of the glacial landscape has eroded away, although local patches of drift can still be found. Closer to Hudson, we see the lightest blue color marking the edge of the very youngest glaciations, which melted out of the area about 15,000 years ago. Well, what's the evidence that geologists use to determine these sorts of facts? Well, one big line of evidence is the distribution of glacial erratics such as this. Another important line of evidence is the distribution of very distinctive landforms. Here's a recent glaciated terrain in Baffin Island, Canada, with rolling hills and basins and poorly developed drainage. If you add trees and houses, you can get Minnesota or western Wisconsin. The landscape holds a signature of the geological agents that shaped it. We're up in the Badlands near Roberts, Wisconsin, where a lot of people do snow tubing and other kind of winter recreational activities. And the rolling landscape you see behind me is typical of the kind of terrain that's left by glacial moraines. These sets of deposits here were left by the most recent glaciation in our area. The valleys are called kettles, and the hills are features called kames. Cames form at the end of glaciers where the melting glaciers get stagnant and are dumping a lot of their sediment load. The cames themselves form where meltwater filled holes in the glaciers with sediments. And these glacial filled holes are then left behind as hills when the ice finally melts out from around them. We're at Twin Lakes near Roberts, Wisconsin. Twin Lakes are an example of kettle lakes. Kettle lakes form when you have iceberg-sized masses of ice that get removed from the main melting glacier and they get stranded and covered and buried with sediment. When the climate warms up and the iceberg masses of ice melt, you get depressions, and when the depressions are below the water table, you get lakes such as Twin Lakes. A lot of Wisconsin's lakes are actually kettle lakes in origin. We're in an active gravel pit not far from New Richmond, Wisconsin that's developed in glacial drift. These are great places to look for rocks, but you should never go into a gravel pit without the owner's permission or knowledge. And you shouldn't go in without the proper safety equipment either. Right at the base of the wall where you see all the pebbles and cobbles, that's called glacial till. Till is left directly by the melting ice, and as the ice melts it mixes together and just leaves behind very large particles as well as small particles mixed together. On top of that, the more well-layered material is called glacial outwash. That's left by meltwater rivers draining away from the front of the glacier. One reason why gravel pits are such great places to look for rocks is that the glacial ice has churned all sorts of different rocks together. So you might find granites in here, and basalts, and quartzites, and gneisses, and all sorts of different rocks all mixed together. If you're lucky, you might even find some Lake Superior agates. Here are some Lake Superior agates that were collected from our area. These are sort of large examples, but smaller ones are relatively easy and fun to find. Lake Superior agates form when gas bubbles in ancient lava flows fill up with fine silica. Here we see an agate still in its matrix. It's a lava flow that's over 1 billion years old. The agates are hard and weather out, and they can survive long transport by ice and water. We can also find the remains of Ice Age plants and animals in this glacially deposited material. One of the more spectacular bits of evidence for the Ice Age climate in our area is this fossil that's on display in the University of Wisconsin River Falls campus down in the Agriculture Science Hall. This is a portion of a mammoth tusk, and this tusk was found by a physics professor, Dr. Wayne Succo, and his brother-in-law when they were walking along the Kinnickinnic River down in Clifton Hollow. They found this down along a sandbar and worked it out and subsequently donated it to the school. This painting by Zdeněk Burian shows what River Falls, Wisconsin may have looked like 15,000 years ago. Carbon and other isotope dating of such remains helps us determine the age and sequence of events. I'm in Man Valley, a few miles west of River Falls, Wisconsin. When those glaciers melted back, they not only left a lot of sediment behind, they also left a lot of meltwater, and that meltwater had to drain someplace. So out in Man Valley here, we have a very wide, complex valley system, but there's no river in it anymore. This valley was cut and then filled by those meltwater rivers from the glaciers further to the north. Once those glaciers melted back and were gone, these valleys also disappeared. Around River Falls, we have other remarkable Ice Age sediments. These are clays that were deposited in lakes next to melting glaciers. The layers are called vars, and each set of layers represents a year of sediment deposition as the lake froze in winter and then thawed in the summertime. The largest lake in our area was called Glacial Lake River Falls and was here for quite a number of years. At the time it formed, local drainages were dammed up by glacial ice, so the water backed up until the ice melted away. Once that happened, the lake drained rapidly away. The glacial-derived sediments are a blessing. Much of our very fertile farmland in Wisconsin is in soils developed on these Ice Age materials, either from the material directly left from the ice melting or from the wind and water deposit sediments associated with their retreat. Indeed, as I hope these short programs have demonstrated, we live nestled in a landscape recording unambiguously the actions of ancient rivers, oceans, and glaciers.